Welcome back to another lecture from Organic Chemistry. It's always a pleasant to see you watching my videos. And please send me email or leave me a comment, and I will do my best to get back to you as soon as possible. Okay, so the subject that we picked for this lecture is we want to see effect of a ring on CO frequency, CO, like double bond CO frequency. Okay, so when it comes to angles, when it comes to rings with a smaller number of, like with a smaller number of members, and we say we have angle strain. What does it mean? It means the bond angle, okay, bond angle for carbon with sp3 hybridization is something less than 109.5, which is the ideal for carbon with the sp3 hybridization. Anything less than 109 is going to make it unstable, okay? So let's talk about the strain first, effect of the hybridization, and then we're going to go back to CO frequency. Okay, I want to remind you a couple of things. First, okay, if you talk about sp hybridization, you will be mixing s plus p. You get two orbital sp, and the bond angle between them. Okay, the bond angle. This is the bond angle we're talking about. It is 180, and we have 50% s character plus 50% p character. Okay, I want you to highlight this number and track the s character, and compare it with with the bond angle, okay, or track the bond angle while s is changing. Okay, next we are mixing s plus 2p, so we have 33% from s plus, you can say 66.7% p character. Okay, so now this one went down to 33. Okay, how about the bond angle? The bond angle this time is going to be 120, and where is the bond angle? This is the bond angle I'm talking about it. So if you go down from 50 to 33, bond angle from 80, and 180 will go down to 120. Okay, let's go and talk about sp3 hybridization. This time we have a 25% s character plus 75% p character. Okay, again, highlight s character, and this one represents the bond angle. So I'm going to call it theta, and expected theta is 109.5. Okay, zoom out. So when we have sp, because we have 50% s character, we got 180. We dropped the s character to 33%. Bond angle went down by 60 degrees to 120. You go down to 25%. This time, half of the 50%. Bond angle is 109. So the less s character you have, the smaller the bond angle will be. Listen carefully. The less s character you have, the smaller the bond angle. Or how about this? The more p character you have, the smaller the bond angle will be. Okay, so that's another way to look at it. Okay, now let's talk about a ring. Okay, we have a ring. That ring, okay, it has carbons, and those carbons, they are supposed to be, octahedral. Like an octet. My bad, octet. And the hybridization, because it's a sp3, I expect the bond angle to be 109. So expected theta is 109.5 degree. But clearly, we know it's way far, and the bond angle here is just 60. Okay, now the question is, how do you want to make it 60? Okay, system is not going to be stable because the bond angle is not 109. We say the system has angle strain. Okay, so the angle strain, you will see it whenever theta for carbon with sp3 hybridization is less than 109.5 degree. So theta is less than 109.5 degree with sp3 hybridization. Okay, so now what will happen? Carbon is going to try to make bond with neighbor carbons. Okay, and in order to make those bonds, okay, it's going to use more p character. Remember, we have 75% p character. It's going to take majority of the p character and use them for two carbon-carbon bonds. So we are left with more s character. Okay, more s character. Okay, so here I'm going to write here. We're going to use more from p. Okay, more also from p orbital, okay, to make carbon-carbon bonds. Now we're going to have more s character, okay, more s character. Okay, so you're going to use maybe let's say 50% of the p. You're going to use them to make those two carbon-carbon bonds. You're left with one from s and one from p. In that case, I'm going to say the s character that left is something around 25%, and 25% for each bond. Okay, that's good. Okay, now the effect of it. Carbon has more s character to make bond with hydrogens, with those hydrogen. And it means this bond is going to be shorter. Same thing here. And because they get shorter, why? Because of more s character. More s character. They get shorter, and very soon they will start repelling each other. because they are too close to each other. And that's going to increase the bond angle between those two hydrogen from 109, from 109.5, it will go up to 114. Okay, 114. So for this bond, I'm going to highlight this. For bonds that they are pointing out of the ring, we have more from s orbitals. We have more from s orbital. Okay, more character. Okay. Keep this one in your mind. Okay. Now I'm going to take this. Okay, and I will draw a triangle. Okay, next, okay, I'm gonna, let's say, put here carbons. So I have carbon, carbon, carbon. Okay, we can attach two hydrogens there, two hydrogens here. Okay, and let's see. We're gonna make this carbon active through making double bond with oxygen. Okay, now we said carbon is using more s character with atoms that they are out of the ring. That means carbon is going to apply more s character to make a bond with oxygen. So what will happen? Okay, what will happen? This carbon, because it's using more, from s orbital. The CO bond will gets shorter. And because it's getting shorter, you need to use higher wave numbers to stretch it. Okay, you need to use higher wave numbers to stretch it. Okay, and that's completely depends to the bond angle. The smaller the bond angle, the more s character you have to use with other atoms. Okay, so now let's compare different rings, and also we will highlight the CO stretch and stretching frequencies. Okay, so we need to have we're going to use more s character to make bond with other atoms. Here, I have a ring. The first ring, it has 6 members. This one, 5, 4, and here, 3. Okay. Now, bond angle for this one is 60. Here, the bond angle is something around 88 or 89. Okay, 88, 89. Okay, this one is around 108, and here is 109.5. Okay, this is sp2. Okay, sp2. Okay, we have sp2. Okay, and that carbon is sp2. Okay, and of course, oxygen also is sp2. For all of them is sp2. The only difference between them is going to be the size of the ring. As the ring gets smaller, frequency goes up. Why? Because you need to have more. Okay, you need to have more s character to make a bond with other atoms. Why? Okay, because of the strain, like the angle strain. Okay, as the ring gets smaller, you will be using more from p orbitals, and you're not going to touch the s orbital. Okay, what do you do with the s orbital? You will use s orbital to make a bond with oxygen, and because s is too close to the nucleus, it will pull oxygen closer to itself. That means oxygen gets closer to carbon, and because it's closer, it's going to cost you more energy to stretch it or to vibrate it, and that's the effect of ring on frequency of the CO or the carbonyl bond. As you decrease the size of the ring, frequency will go up.